So on Tuesday, you guys are just covering classes, right?
Yeah, it was composition inheritance together.
Nice. And so the challenge was to create single responsibility classes, implement clean and flexible interfaces, and use composition to give structure to more complex objects. Cool. So we have a release 0 where you're designing the structure, and then you add some additional features in a subsequent release, and then you expand, you add more features. I saw 7 of you were able to push PRs. And before I pick one of these, does anyone want to volunteer walking through their code? All right, no volunteers. Let's just start reading through some of this code then. Let's see, what has the least number of files? Oh, this one's nice. Nice and succinct. All right, we are defining a class, ice cream. We are initializing self and flavor. We are also setting a ready status to false, a status description to none, and a freeze time, which has a default value of 0. We have a method called getFlavor, which will retrieve a flavor. And we have a second class, or we do not have a second class. I guess this was removed. That must have been from the template. So we're just adding additional methods to ice cream. We're adding a freezing method. It looks like what this method does is it checks for a ready status. And if it's not in a ready status, then we set it to a ready status. This must be the method that's called when we check for when the ice cream is ready. Or maybe not, because we have another method called isReady. If ready is an if else statement or expression, I should say, because it's multiple statements. If one is less than the instantiation's freeze time in hours, or I should say, actually, I see this now. If the freeze time is between 1 and 4 hours, then we describe as watery. If it's between 4 and 8, we describe as almost ready. Between 8 and 12, ready. And anything over than 12, it's freezer burned. Okay, and then we add a freezer class down here. In the freezer, we are initializing a storage that we are going to use to store ice cream objects. And we have a method to add ice cream. We append ice cream that is passed to it. So we also have a method to remove ice cream. This one's going to be a bit of a side note right here. A few of you may have already noticed these little symbols in your pushes. What this is basically saying is Git wants a new line at the end of a file. If we click on it, we might be able to get the error message to pop up or not. It does not want to be nice to me today. The solution for this is really simple. You basically just add a new line, and you add a new line with, by default, I think the right return to use in VS Code is a shift return. That's a soft return, and the difference between that and a hard return has to do with how Git interprets the new line. I'll try to find some documentation on that from Git itself so I could share that later with you guys. But anyway, back to ice cream and freezers. So we now have a test. Hold on, actually. We have an ice cream class and we have a freezer class. Can anyone tell me where the composition is happening?
The list of ice creams within freezer.
Okay. Yes. So if we contain instances of the ice cream class inside a freezer, then we should also be able to access their methods, which is successfully accomplishing the goal of composition. Cool. So let's see. In this unit test, we are running a few tests. The first is to see if ice cream is ready, and we have one to test for when the ice cream is not ready. I want to see, there we go. There's a test I want to see. Test add ice cream. So mango is a flavor, and we instantiate an ice cream flavor called mango. We then instantiate a freezer, and we add the mango ice cream to the freezer. And we assert that mango exists in the freezer. This looks good to me. Whose is this actually?
That is mine.
Cool. Sandy, do you want to pull it up in your terminal and run us through the test?
Yeah, just give me 1 second.
Sure.
Okay. I'm working off of one screen here, so I think that should be it there. This is my test. And so it runs all the 7 tests that I set up. And then I had some print statements in my main, which is what comes out as well.
Nice, solid. Pick one or two of these tests and just talk us through it.
So for this one, I think this one was the hardest part for me. The test freeze not ready. So I initially in my main test, I initially set it default status as false, so it's not ready. So then I assert it false, and so that will come out, that will run. And then I call the freezing method, and so that means once it calls, it says strawberry ice cream is not ready and has been placed in the freezer. And then after I run this, it's been in the freezer. Then after calling the freezer method, the ice cream now should be ready. So this ready status changes from false to true.
Where is time passing?
Time passing is in here.
Okay. I'm curious why, if we go back to the test that you just talked us through, why are we validating when the ice cream is ready?
Because then if it's ready, that means that this freezing method successfully worked.
Well, I get that part, but one of the concepts of unit testing is that we want to break down functionality in its simplest form and really just test one thing at a time. And based on the name of your test, we actually finish your test at line 14. Once you've asserted that,
Right.
there you go. Yeah, exactly.
I see what you're saying. Yeah, I guess I could have broken it down.
Cool. Yeah,
Just
that's
overcomplicating things as always.
no, I mean, it's totally natural to think more like a human than a program. So it definitely makes sense. But the more that you start to get used to unit testing, that's kind of how you'd like to think about it ideally.
Okay,
Awesome, solid work.
thank you.
Does anybody else want to, I think I already know the answer to this, but does anybody else want to run through their solution for ice cream and freezers? Cool. All right, let's just dive into what is it called? Databases and CSVs. Am I still recording? I hope it is. Oh, it is. Yeah. Cool. Databases and CSVs. You should all already be familiar with databases and CSVs. But let's go over it from a high level anyway. What is a database? It's an organized collection of structured information. So it's often controlled through database management systems like, and there are languages like PostgreSQL, MySQL, and these are, well, specifically PostgreSQL is the structured query language that you're going to be using in the curriculum. So,
Are you expecting to be sharing your screen right now?
oh snap, it's not sharing. All right, yeah, give me one sec. I don't know. Oh, right, I stopped sharing so Sandy could share. Thanks for pointing it out. All right, can you see this now? Cool.
Yes.
So databases. We have databases, it's basically a way of managing data. If you haven't heard of the term CRUD yet, it's a very simple term. It basically means create, read, update, delete, which is the basic functionality of a structured query language. Let's see. So some common examples of database management systems: MySQL, there's Microsoft SQL Server, SQLite, MongoDB. We, again, will mostly be using PostgreSQL. When we get to the portion of the curriculum where we are creating database diagrams, you might play around with some other management systems then, just because some of the free tools online don't support PostgreSQL. But the syntax is very similar, regardless of what you're using. If you learn one structured query language, it should be very easy to pick up and learn another one. So, what are the differences between databases and CSVs? Databases are dynamic systems for containing data in multiple structures, whereas CSV is more static. It's a static format for containing data within a single file. Databases are large and monolithic, or they can be, I should say, whereas a CSV can be too, but that kind of defeats the purpose. CSVs are useful for quickly transferring this data in between states. So what does CSV stand for? Does anybody happen to know?
Comma separated value.
Exactly. That is all CSVs are. They are just comma separated values stored in basically a very basic text file. So aspects of the CSV format. One, it's a delimited data format, which means it's a boundary specific sequence. This is mostly important when it comes to how you plan to manipulate and parse through that data in whatever environment you're working in. So Python may slightly handle this data differently from JavaScript, slightly differently from Ruby, slightly differently from C#. CSV is used for data manipulation, and it's a tabular data storage, which is basically to say it's table data that can be broken down into rows and columns. The simplicity of the CSV is what makes it super accessible. It's easy to use, it's self-explanatory, and it's readable by both humans and applications. It's fast, it's easy to read and write, and it's very memory efficient and compact. A little bit about the history. The format existed before the first personal computer even came out. So the IBA Fortran compiler designed in 1972 was used It used this format before freeform input output was defined in 1978. RFC 4180 was, I believe, an organization that, or no, it's a standard that was proposed in 2005 by the organization W3C. So the standards that were proposed by RFC 4180, like we saw in a few slides earlier, it's a delimited structure. So it's value separated by a single comma character. Records and rows are terminated by new lines. And specific character order encoding, byte order, or terminator formats are not required. So it doesn't really need a lot of special characters for the machine to understand how to interpret the data that it contains. Fields with embedded line breaks must then be coded so software knows how to handle this embedded data and treat it properly. Leading and trailing spaces and tabs are considered part of a field and must not be ignored. So if you are running into formatting or compatibility issues, these are the kind of things that you want to investigate when troubleshooting. So why understand CSV standards? Here are a few examples. A software engineer writes and tests an application from the terminal to handle CSVs containing customer records. Super common example. Or when a fraud team submits CSVs to an application generated from Excel, the application breaks. SEs come in to investigate and release a fix. Just a few other generic examples would be like communication with business folks, reporting on data, passing data quickly between teams if that data needs to be examined or used in any way. Some common CSV conflicts. So as I said in a few slides ago, things like spaces and the placement of quotations are pretty important in CSV because different interpreters may interpret these in very different ways. So again, this is the sort of stuff you want to keep an eye out for when you're troubleshooting CSV conflicts. Not all implementations support embedded line breaks. So you could have in your text file or whatever, your script, what looks to you like there's a line break, but you might see when this gets rendered on the front end of an application, the line break is ignored. So that's just the sort of stuff you want to be mindful of. Yeah, this is kind of like a very rough example of what something on a front end might look like, pulling data from a database. You can use things like the new line syntax, which is a /n to ensure that the front end is creating a new line, but at the same time, it boils down to what interpreters you are using. It's very possible for that new line character to not be recognized as a new line, and that's when you recognize or see things like this in the front end. I'm sure you've probably stumbled onto websites by now where you've seen things like really just random symbols here and there. That's just an example of bad syntax handling. Let's see. It's a little more about common issues to troubleshoot. Right, headers are optional, so be mindful of whether data that you're working with has headers or not. How you write your code to handle a CSV file. You should be prepared for cases in which you'll have those headers and cases in which you won't have those headers. For example, in a workplace environment, you might design an application used by different teams who submit these CSVs to read these CSVs. Some people might forget to include the headers. Some might include the headers. It really boils down to who the person is and what they are more comfortable with, because not everybody that you work with will be comfortable with technology or as fluent as you are going to become. So these are the things you want to keep in mind when you're writing software applications, edge cases, basically. That's it, because we are now going to switch gears to today's README. And it's pretty much the same stuff. We talk about databases, how when we interact with the database, we are querying using SQL. And let's actually just demonstrate how to manipulate data in a CSV with Python. So we have here a very basic CSV file. As you can see, comma separated values, the comma is the delimiter. The new line is the break. It's what distinguishes new rows. And from here, we can create a Python script, which I think I've already created. So let's just, or I guess not. Py CSV.py. If we were to add this line of code, CSV is a built-in module that you can import and use anytime, but just remember, you do have to import it. From there, you could call the open method and pass in the name of the CSV that you created, in our case, nflteams.csv, as a CSV file. CSV file becomes the variable that you will be using to treat it. So it really could be anything, like if this is, I don't think it's confusing. We'll leave it as CSV file, but again, it could be anything. So we could even change it to CSV file RAM. We then create a variable, an empty variable at first, called CSV reader, which we are going to associate with the CSV module's reader method. This method takes in the file param, basically the variable we use to store the CSV file, and it reads it. It iterates through the data in the CSV file. So for every row inside of CSV header, let's print the row. Let's see this in action. If we were to call CSV.py, oof, doesn't like that. One reason it might not like that is we might need to import. I always can't remember which is which. These are a few other modules that will help with file navigation, file hierarchies. Oof, of course, it still doesn't like that. Let me double check an example I had earlier today. It's a solution that I'm going to be sharing with you guys later on for the JSON CSV assignment. Save it. Oh, no, there it is. So what am I missing exactly? Oh, I see. It's in a different directory. All right, it is in a directory called JSON to CSV. So let's add JSON to CSV. And now it should work. Let me actually check if it's in that folder. No, it's not in that folder. It's in a different folder. Where is this file? Where did I make this? I'm just going to make a new file. Because I apparently can't navigate my folders. Let's copy, paste, save, and Gonna remove this. This period tells us that we want to search from the current directory. Let's save. Let's pray that it works this time. Whoops, wrong file or wrong command. I'm not trying to open that up. And nice. We are now reading from this basic CSV. For every row in the CSV reader, we are printing a row. Easy peasy, a lot easier than I made it look just now. But let's see. This is using a reader method. Reader is not the only method inside of the CSV library. We could also use a dict method, which treats the data as a dictionary. So if we were to use dict reader instead of reader, we only have to replace where this method is being called. Everything else can stay the same. Now let's look at the results. Now, instead of just having a list of the values, we have key value pairs. We've got a dictionary. All right. So modes and CSV classes. There are different modes in CSV classes, and we can access these different modes by passing in an optional parameter. So let's say we want to run the open method. Oops, wrong location. Let's say, I don't know, I guess it wants us to pass in W, which is telling the interpreter that we want write only. So now that we're setting the mode to W or to write only, let's call the CSV writer instead of the dict reader. We're gonna, oh, that stays the same. We are gonna write new rows to this file. I need to replace the variable that I am defining. And let's just copy paste this. Now let's call this script again. Yes, we are missing, or just want to replace this, but so I ran the script, it did its thing. Let's look at the CSV file. We could see that this overwrote the previous data. We want to undo that, so let's go back and copy the original data. And let's now so we overwrote everything. Remember that W mode overwrites everything. If you wanted to append to the end, we have to change the mode to A for append. So let's change our mode to A. And let's try calling this method again. Yeah, I'm going to call the method first before I open the file now. Okay, it's been called. Now I open my file and we can see that we've added these new lines, but it is squashing giants into the same row as jets, which is no bueno. So let's see. If you didn't have a new line at the bottom of your file, it may have smushed the two lines together. It's a good habit to have an empty line at the bottom of all your text files. This is one of the reasons why GitHub complains about lacking new lines at the end of your files. It also affects how Git counts the number of lines in your file. So that's why you see that little red circle and minus sign if you don't have a final new line. Well, that's about it. Let's talk about today's challenges. There are 2 of them. The first is fairly easy, so I'm hoping you should be able to get to the second one as well. And any questions, by the way, before we talk about the challenges?
Yeah, if you have a very large CSV, I know in some IDEs you're able to see the CRLF in the CSV in the IDE. Is
Mhm.
there a way to do that in VS Code, do you know?
What are you trying to do?
Like you're able to see like the CRLF like highlight in the code or in the file.
The CRLF?
Yeah, at the end of the file, like the new line.
Oh. I'm not sure. Let me try to, let me get back
Okay.
to you on that one.
Okay.
Okay. All right, so we got 2 challenges. We've got word guess, where I think you've worked with this challenge before, but this time, or maybe not. This time you are doing with WordPress, you are grabbing files or words from a file called words.csv. All right, and there are a few requirements. And then the next challenge is JSON CSV, which is a little more practical. JSON basically stands for JavaScript Object Notation. It's used widely on the web. And the goal of this challenge is to go into one of these data sets. There's a repository of data sets. There's all sorts of data sets. There's even a data set on Pokemon. Take one of these and save that JSON file into your project. Then read from that JSON file in your Python class and output a CSV, converting the data from a JSON format to a CSV format. A few things to keep in mind. The way these data sets are formatted, they're sometimes nested. So be mindful of that. Just glance through the data set and plan ahead, pseudocode, plan how you're going to write your software to pull this data. In this example here, we don't care for message success or number at the very end. We really just want people. So if I were to write this, I actually did write this. I'll show it to you guys later on. I added a way for the script to check specifically for people based on a parameter that's passed in when the class is called. So you could do something like that to target the specific data set that you're looking for. And yeah, just grab any one of these and play around with that data. Any questions? Awesome. Let me stop sharing. Feel free to take a break. Be back in 15 and I will open out the breakout rooms.